right triangle day 2. Okay, so this is the second video of this lesson. I wanted to go back to this question for a moment, and I wanted to show you how you could check. This is question number 3. How you could check your answers on the calculator. So this will be beneficial for some of you who are not sure if they got the right answers when they did the factoring. So what you're going to do when you go to your calculator is in the y equals button, type in this equation, x squared plus 5x minus 36. So the x is here, and you can press the square button here, x squared plus 5x minus 36, and then go to the table. Now the table you'll find by doing second graph, and there's a table. What you're going to look for, you're going to look in the second column, the y column, look for any zero that you have. There's a zero there. So if you find a zero here, that's going to be one of the solutions. Let's see if that is in fact true. Yes, x equals 4 is a solution. Let's see if there's any other zeros in the y column. Not this way. Let's go the other way. There's another 0 right here in the y column. And you see x is negative 9, x is negative 9. So that is a quick way to check to see if you got the right solutions. Now, just because we got these two solutions doesn't mean that these are both correct. We have to reject this answer because you can't have a negative value to represent the length of a side. So x equals 4 is the one and only good solution to this problem, okay? So that's a good technique that you could use the calculator for to help you check your work. All right, let's go on to the next problem. Okay, so this was an actual regions problem, a multiple choice regions problem. The issue with this particular problem was that they basically didn't give you any of these. They gave you one diagram. Let's see what it says. It says Kirsty is testing values that would make triangle KLM a right triangle when LN is an altitude and KM is 16. Which lengths would make triangle KLM a right triangle? Now only sides that would make the correct proportion would actually work, right? So the question is, they gave you one triangle to work with. You would need to put these numbers into the diagram and see if the proportion worked. But if it didn't work, then you'd have to erase the numbers on the sides and go and rewrite the numbers. So you would have really had to work in pencil. I'm sure a lot of people, especially on the regions you're supposed to be working in pen, they would have thought, what am I supposed to do now? Maybe just cross out the numbers and put the new numbers in. So we made this a little bit easier. We made it so that you can have four diagrams, so you can work for each of these separately. All right, so I'll show you what I mean. I'm going to do one with you, and then maybe you can pause the video and try to see if you can find the answer yourself. So I'm going to do choice 1 here. It says LM is 13 and KN is 6. So let's think about this. Would we do hills or SAS here? There's nothing on the altitude. There's something on the leg, so it's going to be a hills problem based on the numbers they gave us for choice 1. So how do we set this up? It's hypotenuse, which is 16, over leg. That's the leg. Leg is 13. You use the same leg again, but then you use the segment directly, well, in the same side of the triangle that you had the leg in, this segment NM. Do you know what that's going to be? They didn't seem to give us a number there. Is there a way to do this? Yes. 16 minus 6 is 10. So the number you want here is 10. Cross multiply, 16 times 10 is 160. 13 times 13 is 169. This is not true. This proportion does not hold. Choice 1 is not the correct answer. So why don't you pause the video and try the other ones. And I'm going to actually continue. You could use this time to try them. I'm going to continue on. Let's work on choice number 2. LM here is 12. And NM here is 9. Again, we're going to do hills because there's something on the leg. So let's see how that works. It's going to be the hypotenuse, which is 16, over leg 12 equals that leg over the segment. When we cross multiply those, 12 times 12 is 144. 16 times 9 is 144. There's the correct answer. Choice 2 is the correct answer. Now, if you didn't wind up on the right answer right away, I'm just going to go through the other two. If you got this on the second choice, you're good to go. You don't have to do anymore. I just want to show you why these don't work. I'm going to do it really quickly. Okay, number 3. I'll do 3 over here. KL is 11. KN is 7. The way you'd set this up, again, it's hills because there's a leg and the segment. So it's 16 over 11 equals 11 over 7. Cross multiplying those, you get 16 times 7 is 112, and 11 times 11 is 121. That's not true, so choice 3 is no good. And let's try the last one. LN is 8. LN is 8. NM is 10. Oh, this would be a SAS because there's something on the altitude here. This piece right here is going to be 6 because this plus this has to add up to 16. 6 over 8 equals 8 over 10. 6 times 10 is 60. 8 times 8 is 64. Not true. So clearly these are not the answers. We knew it was choice 2, but I just wanted to show you how it worked out. All right, last problem. Okay, so this problem here, we have same usual diagram. You got the right angle there. You got an altitude because it's making a right angle with the base. It's asking you to find IJ, this side. It's asking you to find JM. It's asking you to find LM, and it's asking you to find IM. IM we could find after we find LM because it's just this piece plus this piece. You're really best off finding this first, the LM first, okay? Because without this whole piece, you're not going to really be able to do hills. So what type of problem are you going to start off with? A SAS problem. 24 over 32 equals 32 over x. So to find LM, we're going to do SAS. Okay, so you're going to do segment, which is 24, over altitude 32 equals altitude over segment. Cross multiply, you get 24x equals, and that's, let's see, 24 over, oh yeah, that's, I'm sorry, 24x equals 1024. Divide by 24. And you get x is 42.6 repeating. And that rounds, because it says to the nearest tenth, x equals 42.7. LM equals 42.7. Okay, so we got that first part. And by the way, we could also now do IM. IM is simply 24 plus 42.7, and that's going to give us 66.7, okay? So that's IM. All right, now to find IJ, I'm going to use a different variable for this side, and just keep in mind, it's a different problem from this one, so I don't want to use the same variable. If there's multiple parts of a problem, use different variables. Now you might say, okay, how am I supposed to do this? Well, you could clearly do hills, you know, hypotenuse over leg equal leg over a segment. You could also do, if you choose, this triangle here is a right triangle. You know the two legs. You could do Pythagorean theorem, a squared plus b squared equals c squared, but let's practice hills just for the sake of it. This is going to be a hills problem, so IJ do hills. So it's going to be hypotenuse, which is 66.7, over y leg equals y over 24. If you cross multiply that, you get y squared equals 1600.8. Square root both of those, and you get y equals 40.0099. So therefore, rounding it to the nearest tenth, IJ is 40.0. If you're rounding to the nearest tenth, you're going to need that, okay? Finally, last piece, we'll call this Z, okay? Same thing, hills. Hypotenuse over leg equals leg over segment. By the way, if you weren't, remember, we knew the hypotenuse for the whole bottom of this triangle was 66.7. I didn't write it in over here. Maybe I should have put it over here. That's this whole length. That's going to be our hypotenuse. Now we're going to do JM. Here we'll do hills again. So that's going to be hypotenuse 66.7 over Z equals Z over 42.7. Cross multiply, we get Z squared equals 2,848.09. We square root those sides. We get Z equals 53.3674 to the nearest tenth. We get 53.4. So JM is 53.4. I'll circle that too. And you're able to solve all three parts. On a Regents exam, beware that you will be expected sometimes to find multiple parts. You want to give each part a different variable. Each part is a separate problem. Okay, I hope you'll follow this and you'll work on homework number 5.